In this video, I'll be explaining how to solve a system of equations that have three variables using elimination and substitution. Now, three variables is actually graphed differently, obviously, than when you have something with two variables. Two variables are dealing with the x and y coordinate. But when you have three variables, you actually will have a z coordinate along with it, in which case you actually become a three-dimensional point that is in space. So for example, in this case, the 5, 1, negative 2 is a solution for the systems of equations. It always goes in basically alphabetical order of x, y, and then z. So the 5 is going to represent the x, the 1 is going to represent the y, and negative 2 is going to represent the z. Now, a lot of times I put a little line through the z because sometimes it looks like a 2. So now, to prove that it's a solution of the system of equations, all you have to do is plug 5, 1, and negative 2 into these equations. So for example, if I was to take the second equation, and I was to plug in 5 in for x, and I was to plug in 1 in for y, and I was to plug in negative 2 in for z to equal 15, I want to know if the left-hand side does equal 15. Well, 2 times 5 is 10, 3 times 1 is 3, and negative 2 actually gives you a positive 2. 10 plus 3 plus 2 does give you 15, so it does work. Same thing with the first equation and the third equation. So if you were to graph these equations in a three-dimensional figure, you would have a point P that would represent x going out, y going over, and z going up. Now, there are a couple of different types of solutions that are possible in this case. So I'm going to move myself over to show you. There is a single solution, which we just described with the 5, negative 1, 2, or whatever it was. There is a single point in space to where all three of those planes basically will crisscross. There is another instance to where they cross to where it actually is an entire line that is in common, or all three planes could actually be sitting on top of each other. They could all be parallel to each other to where they never cross. And again, there's no points in here because the blue crosses with the green and the pink crosses with the green, but the blue and the pink do not cross at all. So again, you don't have any points in common. And again, here is another place where you will not have any points in common. Now, for this concept, you are not going to be graphing the systems of equations. We are only going to be solving to find the solutions to the systems of equations. Now, let's talk about how, I'm going to bring myself back over to talk about how you actually would solve a system of equations. Now, in this case, it's a pretty easy because I have already given you z. So if I've already given you z, I can go ahead and plug z back into both these top equations. So I have x plus 2y plus 3z equals 6, and then y plus 2z equals 0. So I'll have x plus 2y plus 6 equals 6, and then I'll have y plus 4 equals 0. I'm going to go ahead and get any whole numbers or integers on the same side with each together and keep the variables on the left-hand side. So in the top equation, I would subtract 6 on both sides because that's a positive, so I would need to subtract it, leaving me x plus 2y equals 0. In the bottom equation, I would subtract 4 on both sides, and I would get y equals negative 4. So I already know that z equals 2. I have now determined that y equals negative 4, and now I can actually plug negative 4 into y, substitute it into the top equation, and I'll find x. So x plus 2y equals 0, and y is negative 4. So x plus a negative 8 equals 0. The opposite of a negative 8 is a positive 8, so I would add 8 to both sides, and x equals 8. So I'm actually going to write this as a coordinate point, which is the point 8, negative 4, 2, because the x, y, and z must go in alphabetical order. 8 represents x, negative 4 represents y, and then 2 represents z. In this case, nothing has already been given to us of what it equals, and so we are going to have to actually eliminate variables one by one. Now, I do notice that in the second equation and the third equation, the z's actually eliminate if I was to add them together. So what I'm going to do is I'm going to add the second and the third equation together. So when I do that, I'll get x plus 4y plus 2z equals 16, and then 15x plus 6y minus 2z equals 12. When I add these together, the z's eliminate, leaving me 16x plus 10y equals 28. Now, you're probably going to say, that doesn't help us. We still have two variables. You can't solve for one of the variables yet. You're right. So what we're going to have to do is we're going to have to go back over here to the equations, and we're going to have to choose two different equations to also eliminate the z, so that we will have another equation with x and y. So, I didn't say it was going to take long. It's actually going to take a while. So, let's do these first and second equation. We have 2x plus y minus z equals 5, and we have x plus 4y plus 2z equals 16. Now, the z's are pretty close to being able to be eliminated. They both have opposite signs, which is great, but they do not have the same coefficient. I need to multiply the top equation by 2 in order to have, in order for the z's to eliminate. So when I do that, the top equation will be 4x plus 2y minus 2z equals 10. And then the bottom equation doesn't change, so I'm just going to rewrite it. And now when I add the equations together, the z's eliminate again, which is great. The x's will be 5x plus 6y equals 26. So we have an xy equation. We have an xy equation. So we basically go back to the beginning. You now have a system of equations with two variables, in which case you do know how to solve. So what we're going to do now is we now have to solve this system of equations by eliminating one of the variables in order to be able to solve for x and solve for y. Once we've done that, we can plug them back into another equation to solve for z. So let's just get started. We need to eliminate either the x's or the y's. Now 60 and 5 don't really have anything in common at all, which means the 80, basically 80 would be the least common multiple between them. 10 and 6 do obviously have a little bit more in common. I believe 30 is going to be their least common multiple. So I'm going to try to get the y's to become a 30y. In order for the top equation to become a 30y, I would have to multiply by 3 because 3 times 10 is 30. In order for the 6y to become a 30y, I would have to multiply the bottom equation by 5. So whenever we do that, except we do need opposite signs. They're both positive. It does not matter which one you want to make positive and which one you make negative. I'm just going to make the top one negative. It does not matter. I will get negative 48x, negative 30y, and then quickly 28 times 3 is 84, negative 84. The bottom equation, I will get a 25x plus 30y equals 130. Now we can eliminate the y's, and we're going to add these. So 48 and 25 are going to give me a negative 23x. 30 and 84 is going to give me 46. If I divide by a negative 23, I will get a negative 2. Okay, we have found one variable. 2 more to go. But we can go ahead and easily find y by plugging it back into one of these equations. I'm going to take the bottom equations because the numbers are smaller. So 5x plus 6y equals 26. I'm going to plug negative 2 in for x. 5 times negative 2 is negative 10, plus 6y equals 26. I'm going to add 10 to both sides because it's negative, and I'll get 36. I will divide by 6, so y equals 6. All right, we have now found 2 of our 3 variables. The next step is to plug the x and y back into one of these original equations, and we'll find our z. So I'm going to put it in the top equation because it has the smallest amount of numbers. So 2x plus y minus z equals 5. 2 times negative 2 is negative 4, plus 6 minus z equals 5. Negative 4 and 6 give me a positive 2 equals 5. 2 is positive, so I'm going to subtract 2. Negative z equals 3 because 5 minus 2 is 3. And divide by negative 1, so z equals negative 3. And that is the answer to our systems of equations. And we got to put them in order. X is negative 2, y is 6, and z is negative 3.